Welcome to qnawire.
So we need acceleration here to find the force using this equation. So let's find that first. So first we find V, which is dr over dt. So we differentiate this equation and we get V to be equal to Vx naught I cap plus Vy naught minus g of t j cap. Now for acceleration, we differentiate velocity with respect to time. So this will, since this is a constant, this will go away, and from this expression, we will just be left with negative g j cap. And this makes sense because there is no acceleration in the horizontal direction, and in the vertical direction, there is just gravity which points downward, that is opposite to the positive y or positive j direction. So, yeah. Now from here we can write force vector to be equal to negative mg j cap. Now let's find torque for the first part using R cross product of R and F, and this is equal to negative mg times R cap cross J cap. Now let's do the cross product now. So mg. So we know that for the second term, R cross J cap will be 0 because J cap cross J cap is 0. So this is just the first term that will show up in the torque. Therefore, this will be equal to I cap cross J cap, and we know that I cap cross J cap is K cap. So the torque will be equal to negative G times Vx naught T, there is a mass, and this points in the K direction. Therefore, the torque has a magnitude of mg times Vx naught T, and this points in the negative z direction. Now for the second part, we find torque using differentiation of angular momentum with time. So let's first find angular momentum. So L is given by cross product of R with P, and P is momentum, which is given by mass times velocity. So this equation will then be, mass is a scalar, so it comes out of the equation of comes out of the cross product. So now we are left with R cross V. Now, since both the components of R of I and Z cap will contribute, therefore let's use the determinant rule to find the cross product, because this will be little simpler than writing each component separately and doing the cross product as we did here. But here this was simple because we just had one component contributing to torque. So I'm just writing the components of velocity in the respective directions first. So the kth component is 0. Let me just write the k cap here. Okay, now we have to find, so yeah, so this is the first vector, which is r, not the velocity. Velocity we will write down here in the third row. Now we take the determinant of this matrix and we get this value to be equal to negative 1 over 2 m Vx naught g t square k cap. Now we can find the torque by differentiating L. So except t, values are constants. So they can be taken out of the differentiation. So now we can differentiate and we get torque to be equal to negative mass times Vx naught gt k cap. And as expected, this is same as what we got over here in the first part.